Use implicit differentiation to find dy dx. The equation is 4 times x to the 10th power minus the natural log of y to the 3/2 power plus 4 equals y to the 4th power. You may remember that with implicit differentiation, you take the derivative of a y variable just like you would when you take the derivative of the x variable. Whenever you take the derivative of the y variable, though, you need to immediately tack on a dy dx. So when we go through and find the derivative of all of this, we can go term by term. So the derivative of this first term, we know that we will be multiplying this exponent to the coefficient in front by the power rule. So that will leave us with 40x, and then take 1 away from the power. 10 minus 1 is 9. Minus, over here with the natural log, the u is y to the 3/2 power. So I know that in the denominator I will be having y to the 3/2 power, and in the numerator I will be taking the derivative with respect to x of y to the 3/2 power. The derivative, the next term, the plus 4, the derivative of plus 4 is 0. I do not need to write anything. And then on the right side, I know that I will need to still take the derivative with respect to x of y to the 4th power. So when this happens, the next step is still 40x to the 9th power minus, I know I'm still going to have a y to the 3/2 power in the denominator here, and then the derivative of y to the 3/2 power, we bring the power to the front, we subtract 1 from the power, and since we took the derivative of y, this will be a dy dx. So on the other side of this equal sign, still, the derivative of y to the 4th power is a little easier to compute. That is 4y cubed by the power rule, and then again another dy dx there. So what needs to happen is some simplification of this term here, and then we need to solve for dy dx. So it turns out that with the simplification here, y to the 1/2 over y to the 3/2 leaves you with a y left over in the denominator. And this 3/2 power can also get shifted around so that this looks like 40x to the 9th power minus 3 over 2y dy dx equals 4y cubed dy dx. Now in order to solve for dy dx, you need to push all of the terms with a dy dx to one side of the equation, and anything without a dy dx stays on the left. Then once you get this on the other side of the equation, factoring out the dy dx, and then dividing by whatever is there, will give you an answer that looks like this. So there is your answer. You just need to do solving for dy dx from this point to get this answer right here.